Hello, and welcome to the AI Research Roundup. I'm your host, Alex, and today is May 4th, 2025. Alright, today we're looking at a paper from Hugging Face's trending list, published just a few days ago on May 1st. It's titled T2I, Reinforcing Image Generation with Collaborative Semantic-level and Token-level CoT. So this paper introduces a new text-to-image model, T2I, that uses reinforcement learning and a neat bi-level chain of thought process for reasoning, improving both high-level planning and detailed pixel generation. Okay, so Figure 1 really helps visualize this bi-level chain of thought process. It shows how for image generation, there's first a semantic-level CoT. That's like high-level planning in text, figuring out the scene. Then there's the token-level CoT, which is the step-by-step, patch-by-patch process of actually generating the image pixels, focusing on local details. This really clarifies the two distinct reasoning stages the model uses. Building on that bi-level idea, Figure 3 really lays out the BiCoT-GRPO framework. Okay, so first, the unified LMM generates that semantic-level CoT from the prompt. Then, using both the prompt and this semantic CoT, it generates the token-level CoT, which actually forms the image. Finally, an ensemble of vision experts judges these images, providing rewards that drive the group relative policy optimization training. Alright, so moving to the actual results. These visualizations really bring the benefits home. We see comparisons for several prompts, pitting the original Janus Pro model against versions optimized with only semantic-level reasoning, only token-level, and then the full T2I approach using both. Across the board, especially with tricky prompts needing world knowledge or specific layouts, the model trained with both CoT levels clearly performs best, generating much more accurate and coherent images. Okay, so this table provides the hard numbers on the T2I comp benchmark, really quantifying those visual improvements. It compares T2I against other diffusion and autoregressive models. Well, across various subtasks like attribute binding and object relationships, T2I achieves top scores, highlighted in blue. This shows that overall 13% jump in performance compared to the baseline, even surpassing strong models like Flux.1, especially on complex spatial tasks. Okay, and this next table shifts focus to the WISE benchmark results. It again lines up T2I against diffusion and autoregressive competitors across different categories like cultural and natural science. So, looking at the overall scores, T2I comes out on top with 0.54, which represents that significant 19% improvement over the baseline. It leads in several subtasks too, again surpassing strong models like Flux.1, further showing its broad capabilities. Okay, so this table really digs into why T2I performs so well, showing ablation results. It breaks down performance when optimizing just the semantic-level CoT, just the token level, versus the full approach. Well, the results show that while each level helps individually, optimizing both together consistently yields the best scores across the T2I comp bench and WISE subtasks. This really underlines the importance of that bi-level reasoning for top performance. So wrapping things up, those ablation results really drive home the point. T2I successfully brings chain of thought reasoning to image generation using reinforcement learning. By optimizing both semantic planning and token-level generation together, it achieves impressive benchmark results, tackling complex prompts much better. It's definitely a neat step forward for generative models. Alright, that's our roundup for today. Thanks for joining me.